One of the most costly issues facing the construction industry today is water and moisture problems. And that's why building codes often require water-resistant barriers like this. Buildings get wet in basically two ways. They get wet by water leaks through leaky cladding, and they also get wet by airborne moisture. When moisture-laden air infiltrates into or out of a wall system, it carries moisture with it. And when that moisture hits a cold surface, like an air-conditioned wall or a cold sheathing in the winter, it can condense and cause big problems. Mold problems in homes can be very costly. And anytime the surface relative humidity of a building material gets above 70%, that's the threshold which mold starts to grow. So that's why it's important that we keep building materials dry. Common misconception is that if we have mold on lumber, for example, we can just spray it with bleach and we're good to go. But nothing really could be further from the truth. Mold is an allergen, and the dead mold spores can cause the same allergic reaction in people that the live ones do. So it's important that we remove the mold from any building material, or remove the building material itself. Now, one of the ways that we can do that is simply use as little water as possible and some mild detergent to clean the mold off. And we have to sometimes apply a little elbow grease so that we get and remove all the mold. One of the easiest ways to prevent mold problems on wood is to make sure that lumber deliveries are scheduled so that they're there just in time, so that building materials don't have to sit out in cold, wet, damp conditions where it can foster mold growth. So make sure that you schedule your deliveries properly and make sure that you store the materials on site in a way where they can absorb lots of water. Now, moisture in buildings always goes from wetter areas to drier areas. So, for example, if we get moisture-laden cladding, for example, like brick or stone or stucco that acts like a reservoir to store that water, well, that water can easily wick into building materials and cause lots of problems. And that's why it's important that we have a weather-resistant barrier that has the capacity to dry. Many of these products are almost vapor impermeable. In other words, they don't breathe very well. Well, what we want building materials to do when they get wet, of course, is to dry as fast as possible. And what determines how fast a building material can dry out is the breathability of the materials that cover it up. So that's why we want to have building wraps that have high permeability. We want to have the ability of those wet materials to dry as fast as possible. Now, the only way that wet building materials can dry is by evaporation. And that's a very, very slow process. So oftentimes it's very easy for building materials to get wet because water leaks, water infiltrates into the building very quickly. But it can take days, weeks, or months for it to dry out. So it's important that we have building materials that have the capacity to dry. Now, when we think about water management in the structure, we want to think about the 4 Ds. The first thing we want to do is deflect most of the water away. That way, less water is going to be absorbed into these building materials. The second thing we want to do, when water does get in behind a cladding system, we want it to drain and get out as fast as possible, because the faster that water drains out of a wall system, the less it's going to be absorbed into hydroscopic building materials. Now, the third D in our 4 Ds of moisture management is the drying capacity. When building materials get wet, as I said, we want them to dry as fast as possible. And then finally, the fourth is durability. We want to have building materials that can get wet and dry out, get wet and dry out, and tolerate moisture. So in summary, we want wall systems that have the capacity to deflect water away, that have the capacity to drain, and have the capacity to dry, and we want those materials to be durable. A simple solution to ensure that a building is free from water and moisture problems is to have a complete weatherization system. And basically what that means is a weather-resistant barrier, and you want that to be breathable. You also want to have window flashing systems so that you can flash windows and doors to deflect water away. And not only just flashing window and doors, but that means gable end vents, that means dryer vents, electrical panels, air conditioning line sets, any plumbing or mechanical penetrations that might penetrate the exterior. We want those to be watertight and sealed so that water doesn't get into the building envelope. Now, let's walk through the process of how you flash a window. The first phase of the process is, of course, to make sure you have a weather-resistant barrier installed. And then, before installing the windows, you want to make sure that you put your sill flashing on. Now, a couple different types of sill flashing. My personal favorite is a flexible flashing product that is a butyl-based peel and stick. Now, ASTM E2112 is the standard that we use to flash windows. So we always start by flashing the sill first. Then we put sealant around the 3 sides of the window, basically the 2 jambs in the head, and we put the window in the opening. Then we apply our jam flashings, and that basically bridges the gap between the nail fin and the building wrap. Then we'll take and we'll cut back our weather-resistant barrier so that we can actually put our head flashing from the nail fin at the head to actually stick to the nail fin and then stick to the sheathing. Then we'll pull our weather-resistant barrier down over the top of it and then flash those corners or tape those corners so wind doesn't blow up. Now, we always leave a couple little weep holes at the head so that water can get out in the event that any of that water gets in behind the building wrap. Another important attribute of a complete weatherization system is to have a good air barrier. Now, these water-resistant barriers can also act as an excellent air barrier. We all know that if we go outside on a cold winter day and we have just a sweater on and the wind blows through it, it doesn't really work very well. But as soon as we put a windbreaker over that sweater, suddenly that sweater works a lot better. Well, the same thing happens inside your walls. As air infiltrates into or exfiltrates out of a wall system, that can scavenge away heat. So let's say on a cold winter day when you have a wind blowing, that air infiltrates into the wall system and reduces the effective R value of that wall system because that cold air is scavenging away the heat. We call this phenomenon wind washing, and it can be exemplified here in this infrared thermography. Where I'm at, I'm on the inside of a home, and I've hooked up a blower door on this house, and I'm actually pulling air in from the outside. Now, outdoors, it's about 9 degrees. And so what we're looking at when we see this thermography, we're seeing that the warmest areas are the brightest colors, and the coldest areas are the deepest colors. So for example, as you can see here, air is infiltrating into the wall system, and as we look down towards the floor, we can actually see the studs, and we can also see where the air is infiltrating in and how that area is much colder. Now this creates two problems. One, it makes the wall surface colder, which makes us less comfortable, and it also reduces the effective R value of the wall system. So in the case of a typical R14 wall, even a 10-mile-an-hour wind can reduce the R value of that wall from about 14 down to about 5. Big reduction. So having an air barrier stops this air infiltration and stops the scavenging effects of carrying away heat due to wind washing. People often confuse the difference between an air barrier or water-resistant barrier and a vapor barrier. Building codes often require vapor retarders on the inside of wall systems in cold climates. And the concept is that you're trying to keep that moisture-laden air that's inside the home from permeating through this vapor retarder and getting into the insulation. But the difference between a vapor retarder and an air barrier is that you want our air barrier on the outside of the home and you want that to be breathable. And this lab experiment can demonstrate the difference between a vapor retarder and a breathable air barrier. What we have here are two beakers. One is covered with polyethylene, and the other is covered with Tyvek, which is a breathable air barrier. And we have those beakers basically boiling water. Now, when I take a piece of glass and I go over the Tyvek covered beaker, you can see that the moisture vapor is basically permeating through that Tyvek and condensing on the bottom of the glass. But when I take the glass and go over where the plastic vapor retarder is at, no moisture vapor is getting through. Well, the reason this is important is because we wouldn't want to put a vapor retarder on the exterior of our walls because that could actually trap moisture in the wall system. I'm a big believer that you really don't put vapor retarders anywhere in a structure unless it's required by code. Because when the wall system gets wet, you want it to dry out as fast as possible, and if we have breathable materials, that allows that to happen. And that's why it's important that we make sure that this building is watertight with a complete weatherization system before the cladding ever goes on.